Okay, today we will do some application on the Kale. Kale Macrovision program. As you see, we have this kind of window. We can use this program for the writing source code for 1851 microcontroller and its derivatives, C compiler, macro assembler, linker and hex code transformation, detection and debugging of type codes or written codes, simulation of applications written with peripherals included in the selected target microcontroller operation. Okay, we can do all of those operations on the Macrovision program. It also provides great convenience to the designer thanks to the support of microcontrollers which are produced by many different companies. But for this lecture, as you know, we will use AT89S 8953 as I remember. In here, in the main window, we have some section such as this section is toolbar for us. We have some toolbars on this part. This window is project window. This part is working area, working space, and this part is build output for us. We can use this program for the assembly, C and C++ programming languages, and it supports many features of 1851 architecture such as SFR, SBIT, and etc. The examples given in the lecture notes can be run using this software. Please do it after the whole lesson. Okay, it will be very useful for you. Okay, now we will create a new project file in Macrovision. Let's do it now. In here we have a project tab, as you see. Please click on it and new Macrovision project. Please select it now. If you do it, we will create a new program, and I offer you for all your project file use a new file, okay, on your computer. For example, we should give a name for the folder. Yes, I select it, and in here we should give a name for the project file. I will give first name. Yes, if you do it, as you see, we have a new window, but before it I should say something. In your file path there should not be a Turkish characters, okay? Otherwise it may unfortunately cause the error in some applications. It is so important. In your file path, please don't use Turkish characters, otherwise it may unfortunately cause the error in some application. As you see here, we have some processor family such as ARM, STM, but it is not about us. In your computer, it may be legacy device database section, and in here in this section you can write your microprocessor, or according to the producer you can also select your microprocessor here. Our microcontroller is in microchip. You can select microchip, and you can select our microcontroller, which is AT89S 8253. After this stage, then it will be okay. We have a warning, copy the startup, blah blah. It is not important. You can yes or no. You can do those operations. After do it, as you see here in the project file, we have a new project in this section, but we don't have a working area also. For this, we should click right on the source group 1 and we should select the add new item to group source group 1. Okay, if you do it, we have a new section, new window here. Your program is about what? It is C program, C++, assembly, and blah blah. We should select assembly because we will use assembly programming languages, and write your program name but with the extension, of course. For the assembly programming languages, we should write A51 for the assembly program languages. Arsagun point A51, and if you click add, as you see here, now we have a Arsagun name project file. We have a working space now, and we can write our programming codes on this area. Okay, before the writing your codes, your programming codes, first of all, we have to do some settings. As you see here, we have an option icon here, and also we can do the same operation on the target file. Okay, option for target 1. If you do it, as you see here in this screen, we have many settings such as your crystal frequency. Your device is selected here. The most important thing is that we should create a hex file, so you should select this part. Okay, it is so important. And listing user blah blah, the other part is not important for now, but the output, in the output tab, we should select create hex file, and also here in the target tab we can select the microcontroller frequency. For this lecture we should use 16 megahertz, and then okay. Now we can write program codes on the space area. Okay, before the starting any program, first of all, we should write some routines such as origin 00 hex. It means the program will start from the address which is 00 hex, and then we should use sjump x. It means short jump. The program will branch to the x label. Where is x? Now we can write x here, and program will now here. We can write the program codes. For example, move 10 hex, dialysis sign 30 hex. What will do this program? We should write these two lines for any program. Okay, we will learn in detail in the next lectures. Yes, in here, as you see here, we have a dialysis sign. It means it is a data. 30 hex data will be written to the 10 hex address. Okay, and then before the finishing your program, I will give another routine for you, and I will explain next part. sjump x1, for example, and label is here. Now what do you think, what will be happen on this line? This program will stay on this line. We can accept this line as a routine again. this line, this line, this line is a routine for any program. And then we'll finish the program code with the end comment. And also the fifth line is a routine for any program. Routines, routine, routine, and routine. In here we have only one line command. It is move 10 hex, sign 30 hex. Okay, to build this program, you can click this icon or F7. By clicking F7 or this icon, we can build our micro program. If you do it, in here we have some built outputs, as you see. Maybe we can examine this part. It should see here this part. Creating hex file should be on it, because please be sure hex file is created. You should see 0 error, and warning is not important, but errors are so important. Okay, if you have any error, your program will not create any hex file. Origin 00 hex mean if you compile any program, on the background we have some program codes, and the program code, as you know, is named as hex file or machine codes. We have to download those machine codes to the microcontroller. Okay, microcontroller needs a machine code, and if you write any program and compile it, we will create a machine codes and we will download those codes to the microcontroller. With this command, we say this: those machine codes will start from 00 hex in the program memory. Okay, machine codes created in the program memory, and this directive means that after this line, all of those codes will create some machine codes, and those machine codes will start from 00 hex in the program memory. SJump X and SJump X1 will be explained in detail next time. And also AND is a directive, another directive. Program will finish if see this line. And after all of it, we'll build this program, and then as you see, we have no error, and machine codes now is created on the program memory. How can we see this part? As you see here, we have an icon, start, stop, debug session. You can also use CTRL plus F5 to use it. If you click on it, before this, please erase the startup file, okay? And then click build again. As you see here, we have no warning. Before this, we have 3 warning. It's about startup file. And then click on the debug session. Okay, if you click debug session part, we have some new window here, disassembly. C means it represents the program memory. Okay, program memory. And 0 times 0000 means this is 00 hex address. What is in here? sjump command, sjump x command, and this command is 2-byte command, which is the value 8000 hex. And then the next command is start from the 02 hex, which is move command. Move command, and this clone represents the machine codes for this command. Okay, this clone. The first clone represents the address in the program memory. The second column represents the machine codes for this command. Then the third column is the related commands. In here, the first command is sjump x and the value of its machine code value of its 8000 hex. The next command will start from the 2 hex value because sjump command is 2 bytes. How can we understand? In the hex based operation we have 4 digits, as you see. Okay, and the next command is move 10 hex to 30 hex, that is assigned 30 hex. This is 3 byte command. How can we understand? In here we have 6 digit. Okay, 7 5 1 0 30 and 0. The next command will start from the 5 hex because the move command is 3 hex. If you add 2 plus 3, it will be start from 5 hex, and it is sjump x1. Sjump x1 has the 80f and e hex file. Okay, that's all. That part is about the program memory. How can we see the operations which is done by us? In here, if we don't have memory, in here we have icon, memory icon. We can see the values on the data memory or RAM. If you select one of them, after the selecting memory section, as you see here, we have a new memory window. But we should write a value in the address part, what you want to see, what kind of memory you want to see. Okay, if you write C and as like that, it means we want to see program memory. Okay, and as you see here in the program memory, the first one is 80, the second one 00. We see before on this part already 8000 8000 751030 751030 80FE 80FE. Okay, this is the program memory, but we want to see also RAM. For this we should select another memory window here, and we should write D 0 times 00. Okay, it means we want to see RAM memory, and we want to start from the 00 hex address. If you write here 10 hex, it will start from the 10 hex address. Okay, but we want 00, and then we can execute the program line, and we can see the changing on it. What is mean? Each of these values is the memory cell in the RAM. It will start from 00 hex, then the near it's 01 hex, 02 hex, 03 hex, 05 hex. Okay, it will be continuous like that. And the next line will start from the 1B hex. What do you think about the 00 hex? What we have in the 00 hex? What we have in the data memory in 00 hex address? Bank 0, R0, R0, 01 hex, R1. It will be continuous like that. Okay, this is the RAM data memory. It will be continue R1, R2, R3, and as like that. We have also another window here, registers. We can see the register value on this window. We have all registers and also A, B registers, stack pointer, program counter, DPS not important for now, data pointer, state, second means it will be implemented on this time, okay, program status word. And here we have some bank selecting bits, RS0 and RS1 are represented with only RS here, okay. In here we have an arrow which is highlighted with yellow. Program will start from this line, okay, program will continue from this line, and if you click to F1 or if you use this icon, it means program will continue step by step. Yes, I clicked one time and program will continue to the third line. Why? Because second line program will branch to the X label, and we have X label this line, so program will go to this line. Yes, if we click this part, what will be happen? 10 hex address will have 30 hex value. Before this, we may edit the memory window. The second line will start from the 10 hex. So this memory cell will be 30 hex after the execute this command. Okay, let's see it. If you click one time again, as you see here in the data memory, 10 hex address will have 30 hex value. Okay, and we have now in the next line, and if you click again and again, the program will stay on this line, okay, because the program will branch to the X1, and X1 is the same line, is on the same line. If you click this icon, the program will continue step by step. Each of these lines will be execute step by step. If you click this part, this icon step over, the program will execute all of this line. If you click it, the program will go to the cursor line, okay. Before this, you will establish some breakpoint. We will see in detail the next time, and program will go to the this line. Okay, maybe we can try another code, but before this you have to exit debug session part. Okay, so we will go to the main program again. Let's write some codes on here. For the immediate address, we see an example by using this code. Now we can see the move R0 or R5 to 10 hex, move A R5. If you give a command for your program, you should use this sign, okay. If you use a label, you should use this sign. We can give another program code related to the indirect addressing, but maybe first of all move PSW 0 8 hex. What does it mean? Yes, program status word, but what does it mean if we load 08 hex to the program status word? Bank 1 is selected, and then maybe we can use the same register again. Move A R5. Okay, after writing this code, we will build the same program again by using this icon or this icon. As you see here, the hex file is created and we have no error and no warning. And after doing it, now we are in debug session and program will start from this line again. And as you see here, the program memory will have some another codes here, and you can examine this part, but not important for now. Maybe we can check this command with the opcodes operand section. Before we will use here move direct address and immediate value. What is the hex code of it? 75. As you see here, the hex code is start with the 75. Okay, 10 hex is the destination operand, which is address value, and the 30 hex is the source operand, which is a data. Okay, you can easily see it on here, or maybe we can see the sjump command. Where is it? Yes, here we have sjump command and the hex code of it, 80 hex. Offset means the program will go to the related program line. So second byte is about the program line, okay, or label. As you see here, we have 80 hex value. As the same way, you can examine all of these opcodes or operands. Let's execute the commands step by step again. We are in the third line. If you click one time, and the second time 10 hex has the 30 hex value, and if you click one more time, the R5 will be loaded. What? 30 hex will be loaded 30 hex. And what do you think here? Move A R5, A will be loaded with 30 hex again. Okay, and here, what do you think? What is the A value? Until the line 6, the bank 0 is selected as a default value. But in line 6, we select the bank 1. So the next command is about the bank 1 if you use any register. In line 7, we use R5, but this register is about the bank 1. Okay, bank 1 R5 value is 0. As you see here, all of this are 0, so A will be 00 hex. Okay, okay, let's do it again now. After execute this command, you can see also in here R5 value. Yes, here R5 will be loaded with 30 hex. Where is the R5 in the data memory? 5 hex address 0, 1, 2, 3, 4 and 5. 5 hex address will be loaded with the 30 hex in the data memory. after we use this command, A will be 30 hex, and we can see on this part, yes, as you see, A is loaded with the 30 hex value. Okay, if you click one more time, program status word will be loaded with 08 hex. Where is the program status word? Yes, we can see this value on here. Yes, program status word is 08 hex now, and we can see the selected bank here. Okay, RS1 means bank 1 is selected. And if you click one more time, before this, please be careful. The new register values are 0. How is this possible? R5 is loaded 30 hex, but now the bank is changed. Okay, all registers on here is about bank 1 now. Okay, when you click one more time, A value is 00 hex.